Hey, Mr. Moon. Oh, that language is bad. Oopsies. There we go. Just wrap up this chess game, boys. Sorry.
Taking it slow, saving up cheap before she
Hey, Matt Vasquez. Let me just finish this game up. I started it a little earlier, but it's taken a while. Ugh. Oh, hey, Ethan. I might exit this game. I'm trying to beat this guy really fast. It's gonna be tricky. It'll be over soon, boy. Okay, so after I handled that guy, let's get down to brass taxes. Ooh, a lot of people are here right now. Tristan, Matt, Ethan. Let's see who else. That's pretty much it. Hopefully, everyone's here. So for today, we're gonna be starting a new section. We're gonna be starting our section on genetics. Uh, And I can reserve some time towards the end where we can discuss science fair if you guys have any questions. So we'll dive right into it. Hey Paris, how you doing? Uh, did I read the messages? Yeah. Website where you can play other kinds of games. That's pretty cool. Well, send me the link for it. In the meantime, let's get started on this lesson. Da-da-da. Yes, I did see what you wrote. Okay. So, we're going to be talking about genetics. Genetics is the study of heredity. So heredity is the passing of traits from parent generations to offspring generations, and so on and so forth. Um, for some reason, there's so many spelling errors in the text that I'm starting to notice. So yeah, genetics is where we're going to be focusing our attention for the next couple weeks, and it really starts from a man by the name of Gregor Mendel. That's why our first section in Unit 11 is about this monk, Gregor Mendel. Now, what's so special? Oh, I taught you this freshman year. Well, you're learning it again, but a little more in depth, Matthew. You were in, I think, climb biology the first year. Uh, you're moving up. You're moving up. We're gonna go a little more in depth. So, what did Mendel do? Well, Mendel was he worked in he was a monk, right? He was in a monastery, not the type of occupation you would expect from literally the father of modern genetics. So, what did he do? Well, he was a monk in a monastery, and he operated a garden. And in this garden, he did some really interesting work that literally changed our understanding of biology forever. And he did it with pea plants, ordinary pea plants, the small little round green things that you guys usually probably try to avoid eating at dinner. But nonetheless, it was this seemingly insignificant organism that really kickstarted uh, uh, the study of genetics all the way to our modern knowledge and understanding. Okay, so what's so special about a pea plant? Well, here is a little diagram of a pea flower, and it's interesting. Well, we should before we even begin to discuss genetics itself, we should first discuss just the basic anatomy of a pea plant. Now, pea plants, like most angiosperms or flowering plants, contain both male and female parts. They have their stamen right here, their anthers and filaments, and these parts release pollen. And then they have the female part, which is called the pistil. The pistil is pretty much a structure that can hold ovules or the egg cells, the female reproductive cells of a flowering plant. And what needs to happen is a single grain of pollen needs to enter the pistil, right, from this little opening we call the stigma, and it travels all the way down until it reaches this ovary. This little bulb right here at the end of the pistil is the ovary, uh, and that's how a plant can essentially fertilize itself. It's possible for a pea plant to release pollen into its own pistil and fertilize it that way. So that's important for us when we talk about Mendel's stock of pea plants. Okay, now and again, I'm sorry, when that pollen releases its male sex cells and introduces them to the female sex cells of the plant, we call that fertilization, which makes an entirely new cell with a combination of genes from the male sex cell and the female sex cell. So that's fertilization right there. Now, Mendel had several stocks of pea plants. Uh, pea. He had several stocks of pea plants, and those stocks that he kept were true breeding. What does it mean to be true breeding? Well, a true breeding plant is self-pollinating. Normally, the pea plants are not trying to self-pollinate. They're trying to extend their reproductive vigor to other individuals nearby. But it is possible, again, for a pea plant to self-pollinate. So what happens when they do that? Well, I mean, you're making offspring that are identical to themselves. And no matter how you split up genes in half, right? When you put it back together again, if it's the same genes you initially split up, you get that same combo when you recombine them. So uh, that is the benefit of these true breeding plants, that they make offspring that are identical. So as long as Mendel continued to breed these different generations of his plants, he would know that they were all identical to their parents. Okay. And this is important because he was looking at traits. He was looking at different traits in each generation of his pea plant. So traits, these are characteristics, and they could vary from organism to organism. In pea plants, the different traits were seed color, plant height, in some cases, yeah, the texture of the seed, whether it was smooth or wrinkled, the flower color itself too. The flower right here you see is purple, but there's different colors of flower petals in the pea plants. So Mendel had stocks of plants. For example, he had one that was all tall plants. So every time those plants would self-pollinate, they'd also produce tall plants. He had a stock of short plants. He had a stock of pea plants that produced green seeds and another stock that produced only yellow seeds. So he was doing a very good job to curate these different stocks of pea plants and make sure that uh, they were indeed true breeding and maintain the same traits through generation to generation. Okay. So where does the magic come in? Where does the magic come in? Well, Mendel wanted to experiment with the different traits that he saw, at least the different versions of the traits. So he had a tall plant and he had a short plant, and right, he had interpreted this particular trait as being a different version of itself, right? In this case, it's the trait of plant height. When you have your short plant and your tall plant, two different heights, you have a different variation of that trait. Okay. So he started to crossbreed. He started to crossbreed his different stocks of true breeding plants to see what traits would emerge in the offspring. And he looked at seven different traits. He looked at height again. He looked at seed color. He looked at the texture of the seed as well. He looked at the flower color. A lot of different things. We're not going to focus on all of them, but we're going to be looking at least the ones that were significant. Okay, so what happened when he crossbred these plants? Well, when he crossed a yellow seed plant with a green plant, all of the offspring produced yellow seeds. Okay, it seemed to him that the green trait had disappeared entirely. That it had been swept away by the yellow seed trait. And the same thing happened with other traits. So when he crossbred the short plants with the tall plants, in the very next generation, all the plants were tall. It was as if shortness had been erased, or well, that was what he would initially conclude. But he thought of two different ideas. He thought there were possibly two different things going on. Okay. The first idea he had was that he believed, or he discovered, that an individual's characteristics are controlled by factors that are passed from parent to offspring. So that's a given. The fact that when he took two different types of plants, a red seed, oh sorry, a green seed plant and a yellow seed plant, and ended up with a yellow seed plant in the offspring, means that that trait of yellow seedness is being passed on. So he knows that there was something being passed on from parent to offspring. Uh, Regardless of what trait appears in the offspring, there is definitely some information being handed down. Okay, that's the essence of heredity. Um, yeah, well, Ethan, to each his own. So, the second conclusion that Mendel came up with was the principle of dominance. Okay, the principle of dominance is highlighted here, and I'll explain what this means. The principle of dominance states that some alleles, right? Oh, sorry. Actually, before we gotta talk about alleles first. Uh, so let's go back to the passing of traits to offspring. Uh, so when he was looking at seed color, there were two different versions of that trait. There was green and yellow. Okay, and he believed that there has to be some form of gene controlling the yellow seed trait and the green seed trait. Um, in this regard, we call these different versions of a trait alleles. Okay, So in the case of seed color, your different alleles would be a yellow seed and a green seed. In regards to plant height, your different alleles will be tallness versus shortness. They are different versions of the same trait, okay? Think about it this way. The trait is whatever characteristic of the plant you're looking at. In this case, if it's the height of the plant, right? The plant can either be tall or short. Those are the two versions of plant height. And so we call those different versions alleles, okay? Uh, and moving on, his second conclusion was the principle of dominance. He believed that there were some alleles, some versions of traits that were dominant than others, in a sense that when they combined together, the dominant ones would be the ones that were exhibited in that actual organism. Okay, so an organism with a recessive allele, meaning a non-dominant allele, will only show that particular version if there is no dominant allele present. Okay. Uh, Now, in Mendel's experiments, the allele for tallness was dominant, and the allele for yellow seeds was dominant over green seeds and short plants. So those were the two dominant genes. When he combined those genes together, every single time the dominant traits were the ones that were exhibited. Every single time he took a true breeding green seed and yellow seed plant and bred them together, it always came out, the offspring always came out with yellow seeds. And likewise for tall versus short. The plants always came out tall. So that meant tallness and yellow seededness were dominant. So, what happens? What is happening in this particular study that Mendel was doing? Okay. Uh, let's go ahead and look at a genetic cross, okay? And a genetic cross is a great way to break down how different alleles are distributed from parent generations to offspring generations, okay? Uh, let's go ahead and look at the example they give us in the book. Well, actually, yeah, no, let's take a look right here. So we start off with the P generation, P for parent, okay? And in this particular example, the tall plant is a true breeding tall plant, and the short plant is a true breeding short plant. So they contain only alleles for shortness, and the tall plant only contains alleles for tallness. When you combine those two together, when those two individuals fertilize each other and create offspring, the result is that all of your offspring are tall. And that is just regards back to the principle of dominance. We know that tallness is dominant. Every single time we breed tallness and shortness together, we get tall offspring, right? But what happens here? What happens when we take these offspring, the original, the offspring of the original P generation, and we breed them together? So we're gonna breed this tall plant with this tall plant. Both are the offspring of the tall and short plant. What happens here? Well, in this next generation, oh, let me backtrack. This generation right here, the initial generation of offspring, we call that F1. F for filial, which is relating to offspring or children. Filial is a way to describe that. So F1 would be the first generation of offspring. F2 would be the second generation of offspring. Okay? So if we take the individuals in the F1 generation, who were the offspring of a tall and short plant, and thus contain the alleles for both. When we breed them together, what happens is we get a combination of tall and short plants. So the shortness trait reappeared. It reappeared in the second generation of offspring, so the F2 generation. What's going on with Ethan? Hold on, let me pause for a second. What's happened? Okay, just a bunch of chatter, uh, unnecessary chatter at that. Let's just focus, guys. The quicker we can get through this, the quicker I can assign the worksheet, and we can get started on that. The class ends earlier, the smoother this goes. Okay, so what is happening, right? What is happening? In the F2 generation, something happened here. Something happened between the F1 and F2 generation. In order for one plant to come out short, that means that the parent plants had to have that allele for shortness in it. There's no way for a trait to be passed down uh, if the parent does not have it. So because one of these plants is short in our F2 generation means that both of these tall plants contain the allele for shortness. And in fact, each of them has to contain the allele for shortness because if uh, if we are ever to come up with an offspring that has it exhibits shortness, that means it has to have two alleles for shortness. If it had one allele for shortness and one for tallness, then the tallness trait would be the one exhibited. So this tells us that both parents have the shortness allele. Okay, so uh, how did that plant end up being short? Well, this means that the alleles are separate. They're not linked together. Okay, meaning that there's an allele for tallness, there's an allele for shortness, and in order for them to in order for these two individuals to create an offspring that is short, then the shortness allele from the previous generation had to separate. Okay, let's put it this way. There is a short allele in this parent plant. There is also a short allele in this parent plant. Okay? And at some point during the fertilization, these alleles had to be separated from the tall alleles. Okay? In order for them to end up in this particular offspring and result in a short plant. So that is the principle of segregation, meaning our alleles will separate and recombine to make new combinations. Okay, they can separate, and you can have two tall alleles. You can have a tall and a short allele. You can have two short alleles. Those are the maximum combinations that you can have. And it's all due to the fact that these alleles can separate or segregate from each other. Okay? And they do this during the formation of gametes or the formation of sex cells. So when you are producing sex cells when you're producing sex cells for the purpose of reproduction, you are separating alleles. Essentially, the combinations of alleles you got from your parents, you're separating them out. Okay, either into individual alleles or maybe groups of alleles as well. Okay. So that's what allows this jumping of traits across generation. They can jump from one generation, skip the next one, and then appear in the one after. Okay? So let's go ahead and take a look at a different diagram. In this case, we're going to label our alleles. Oh, oh, uh-oh, uh-oh. What did I do? Here we go. Whoopsie daisy. All right, let's go ahead and take a look at this. So now we're looking at the same cross, well, the F1 and F2 cross. We're not looking at the P cross anymore. We don't need to. But from the F1 cross, if you remember, our original parent plants, they were a tall plant and a short plant. So let me go ahead and mark them right here. Double uppercase T and double lowercase t. Remember, if there is, well, let me explain what this means first. So the uppercase T is the dominant allele. In this case, it is tallness. Okay, and this may all be familiar. And the lowercase t is the recessive allele, and this is the shortness. Okay. So in order for a plant to be short, there cannot be a dominant allele present. That's why this short plant has two lowercase t's. And this tall plant in the parent generation has two dominant t's, two dominant alleles. Okay? And the reason why we established this is because, remember, these were true breeding plants. Mendel made sure that that these stocks of plants only exhibited one trait. All right. So let's go down here. Well, our F1 offspring, the offspring from the initial parents, have the combination of the dominant tall trait and the recessive short trait, meaning that they'll both be tall, right? Because tallness is dominant. Well, segregation, the separating of alleles, works like this, okay? During the formation of gametes, our sex cells, The parent plants will literally separate the alleles and make sex cells that only have one of the alleles, okay? So in this case, this parent will make gametes. Half of them will have the tallness allele, half of them will have the shortness allele, and vice versa for the other parent because it's identical in terms of the alleles it has, right? So once these two plants begin to fertilize each other, essentially share gametes, they will fertilize those gametes at random and make up different combinations. So it's possible for the tall allele from one plant to combine with the tall allele from another plant, and then you get two tall alleles and one offspring. The same is true for a tall allele combined with a short allele. Okay, so we get that there. And we see the similar pattern happen until we get to this particular instance where our two short alleles from each parent happen to find themselves during fertilization and combine to make a plant that has both short alleles. Okay? So that's how segregation works. And that's why it's possible for some traits to skip generations and show up in later generations. Segregation is what's happening there. Okay? And that is pretty much it. Well, okay, Ethan, if we breeded F2, we'd have to choose which individuals we're going to breed, okay? So let's go down here. We would have to determine the actual combination of alleles first before we can make another F2 cross, okay? Alrighty. We're going to stop right there. I'm not recording this, but remember, guys, the textbook is listed over here in your classwork tab of the Google Classroom. Okay, so you can get it right there. I'm gonna go ahead and post the assignment for today, and we will end class rather early, unless you guys have some science fair stuff to discuss. Where is it? Oh wait, I gotta add it here. Okay. Assignments. And first let me make it into a PDF because we had some issues when it was a Word document. No fun. Alright. Microsoft print to PDF. There we go. And save it into weekly homework. This is 11.1 worksheet. Alright. And there it is. Add file. Select files from device. Biology, core, weekly homework, and there's my PDF right there. All right. So it's a two-page worksheet. Well, it's double-sided, so we can just take a look at it together. It comes out really nicely. Again, you can print this out, complete it by hand. You can put your answers into a Google document and send it that way. Although I think you'll have to actually take a picture of yourself completing this diagram, the one that we just looked at when we were talking about segregation. Okay? That's pretty much it. Nothing else to cover. On Wednesday, we will review how to make different individual tables and graphs to complement our data on Science Fair. And let me just check the chat right now, just to make sure that there were no questions about how do you turn in the Science Fair report. Well, it should be a PowerPoint, Mr. Moon, so you can just send it to me. If you're done with it and you made all your PowerPoint slides for the different sections, you can send it straight to me. I am evil. Sorry, Matthew, I'm not evil. I'm necessary. I'm necessary for your guys' education. When's it due? Okay, let's first post it. Okay, 11.1 worksheet. It's going to be due by Wednesday. And again, your method of submission is suitable as long as it is effective in showing all the work and answering all the questions. Okay? All right, assigning this now. Oh, when's the project due? May 17th. May 17th. I've been extending the deadline again and again and again, and I might extend it a third time depending on how the other classes are doing. I've had to cancel science fair in my first period just because they weren't as far ahead We had hadn't really got as started on it as you guys had. Ethan, uh, unfortunately, no, but I can arrange us to do this at a later date. And I think the statements you made about Miss McGee were a little uncalled for. So, I would be mindful of how courteous you're being to others. Even though it's in chat, right? Even though you're at home and it feels a little bit informal, it's important to, at least be courteous. Miss McGee has missed you guys, and she's been trying to get back into these lessons, and, we should be glad that she's here. I understand it. It's an accident, and you probably didn't mean it that way, but you interpret things one way, the other person interprets them another. Alrighty? Tristan, do you have any other questions? Just when you're done with your PowerPoint for the project, you can just send it my way. I already received one from Bryce. Actually, we could take a look at Bryce's project, maybe. Do you guys want to take a look at Bryce's project? He put together a pretty solid PowerPoint. There was some things I wanted to correct from it, but he did a pretty good job. All right, let's take a look at his project. How about that? Okay, so here is Bryce's project, and I know it's okay to share it with you guys because he asked me to share it with the class on last week. Um, a very nice title page, got some gifs there, really creative. Okay, I appreciate that. He has an introduction. Remember, the introduction is optional, but this project was really, it really kind of resonated with Bryce. He likes music. He loves music. He's a musician and he performs a lot. So this is kind of his explanation for what led him to this particular project. Aaron, if you want to do an introduction where you discuss your interest in engineering and DIY stuff, whatever you want, that's fine as well. He has his question here. Remember, each of these sections has their own slide. So there's the introduction, question, hypothesis, materials, procedures, key terms, and then as he needs to, he'll make additional slides for each section. Okay. A couple things that I wanted to point out to him. His materials list. I guess it's suitable. The problem was his procedure. He didn't describe what data to look at. He said, look at the data. Well, what data is he looking at on his Fitbit? Be a little more specific here. Uh, and what else? Also didn't mention recording the data. Uh, so although it's good, it's a good procedure, and he can understand it. It's important to remember that when you're writing your procedure, you're writing it for a person who probably has never done it. So what may seem like common sense to you or logical or practical to you may not be that way for the viewer who is looking at your procedure. So try to be specific. Pretend you are teaching someone who has no idea and no prior experience with what you're talking about, okay? And you need to be specific in those situations. Uh, Key terms. We didn't really talk too much about key terms, but I'll bring them up here. He has a couple key terms, I think 8 in total. So 1, 2, 3, 4, 5, 6, 7, 8. And what he did was he listed some of his independent variables as his key terms. So different genres of music were his independent variables. He was testing sort of how he slept, how his different sleep cycles, how long it took for him to fall asleep, and how long he could remain asleep listening to different genres of music. So that's why he has them listed here. These were his independent variables: ska, punk, metalcore, and deathcore. Okay? And then he also wanted to describe a little bit of just the subject of sleep health itself. So he listed out the phases of sleep cycles. So REM sleep, deep sleep, and light sleep. And again, I can't really point you in any direction to find key terms for your project, but just try to keep in your mind, if you want to explain or provide some definition to your independent variables, you can definitely do that. All right. If you're doing a project with, in your case, Mr. Moon, Your key terms can be things like FPS. Your key terms can be things like what is it? I forget what the chromograph. I forget the name of it. Gosh. The device you use to measure the feet per second. You could also identify some of the. You could define some of the tools you use to measure your specific project. So it's really up to you. Here's his data. And his data, he put his data table here, which is nice. Remember when we looked at our sample graphs, I had data tables that were associated with each graph. And he had his data tables included here as well. So these aren't the graphs themselves, but these are just data tables. And it's useful because I can compare what you recorded in your data table to the graphs that you generated, okay? So he took data on the time it took for him to fall asleep and how long he was asleep for. He recorded the minutes, and he also recorded the time spent in different sleep cycles. So his Fitbit was able to record based on his heart rate and blood pressure, I'm guessing, what phase of sleep he was in. So he's able to chart those out too. How long was he in light sleep for? How long was he in REM sleep for? How long was he in deep sleep for? Okay, once again he correlated them to the genre of music that he was listening to, and he also did no music as well as a control. So that was pretty useful as well. There was one problem here. His data looks great. The graphs were amazing. He used what kind of graph is this? This is time to fall asleep. Okay, so he used what looks to be a line plot, which can also be a bar graph. Instead of different dots, he could use bars instead. But the dots are fine. And he has 2 trials. He said he was going to do a 3rd trial, but you can see that he has multiple tests of the same genres. Okay. So this took him a while to do. It probably took him a couple weeks, and it's probably going to take him, a few more weeks to, or maybe another week to do a 3rd trial of all the genres. Okay, it is a lot. He really went overboard, and this is why I want you guys to pick projects that, well, I mean, it's kind of a little bit too late now, but hindsight's 2020. It's important to pick projects that you're interested in, you have a passion for. So probably the reason why it looks like a lot to you, but maybe it wasn't a lot for Bryce because he enjoyed doing it. Okay. Uh, Hold on a second, Aaron. Let me go ahead and review one more thing. Okay. So remember, he has different graphs. He measured the time it took to fall asleep. He measured how long he was in different types of sleep phases, and he also measured the total time asleep for each of his genres. The problem The problem is that in his conclusion, he only really addressed the time it took to fall asleep. So in his conclusion, I won't have you read it, but the problem was he only really summarized the data from this graph. Okay, he only talked about how long it took for him to fall asleep. He didn't mention the different phases of sleep. He didn't mention the total time of sleep, I think. So he would need to discuss this a little bit more in his conclusion. Um, he made a statement on his hypothesis, that his hypothesis was proven correct. I wouldn't state it this way, okay? Don't ever say proven correct. Just say my hypothesis was supported or rejected, depending on your results. Don't ever say proven correct. You're not making a new law of science. You are simply reporting on the validity of your hypothesis. So we never say proven correct. We always say it is supported or rejected. Okay? Uh, and he also reported on some of the inconsistencies in his data. So the lurking variables that may affect his outcome. Uh, he reported on those as well, and that's it's very good for him to reflect and evaluate what could have gone wrong during his experiment. And then I think he also talked about, let me see here if I can find it. Oh, if I were to repeat this, okay, so he talks about what he would do if he were to repeat the project, and these were simple things. He said that going to bed around the same time each night and trying to do the same amount of activity each day to kind of at least control the other potential lurking variables to get more consistent results. That might be a way he'll repeat it. So all in all, a very, very, very well done project. Some mistakes, some holes here that I pointed out to him, and hopefully he corrects them. But this is a great sort of example for you guys to see uh, uh, essentially what a good project looks like. And even good projects will still have some areas that can be improved. Okay. That is pretty much it. We are going to resume on Wednesday. We're going to go over 11-1. We're going to briefly investigate on Wednesday how to put together different graphs. Okay, so I'll show you guys how you can do it through Microsoft Word if that is the program you're using. I won't be able to explain all the different websites and tools for making graphs, but I can at least show you guys in Word pretty effectively how to make a graph. All right. Uh, Aaron, I'm sorry for keeping you too long. I hope you have fun in the coal mines. Be careful. Try to protect your eyes and your nose and your mouth and pretty much everything when you're in the coal mine. And let me know where that coal mine is. I don't know of any coal mines in California, so that sounds pretty interesting to me. All right. Take care, everybody. I will see you on Wednesday. Make sure you get that 11-1 worksheet done for me. Alrighty? Mr. Holden signing out. Oh, wait a second. Hold on, hold on, hold on. Who's here? Who is here right now? I made a mistake. Matt is here. Paris, Aaron, Tristan. Anyone else? Ethan as well. Sorry. Matt, Paris, Tristan, Ethan, Aaron. Okay. All right. That's who's here. Alrighty. Take it easy.
Profit of me most visibly. I see clear when the world to roll on the analog trail and you look the road. Just stroll to the trees and let your miseries go. Sunshine, hurricane on the highs and lows. Yeah, we can take it all back to the register and start all over from the canister. Let's break it all down into pieces of bright moments that pass by like a meteorite.
Gigi, I've decided not to leave this town. Maybe I can stay and find some other nice people who will like me and accept me for who I am.
Trusting your spirit, yes, yes, that's exactly what I'm talking about.
Is that the armor one? My bad.
That's our
Hey guys, what's up?
So,
Hello.
Is that Waffles?
Waffles?
That's right.
That's true.
Sorry.
Waffles does have a very cheerful voice as well. In
Sorry,
fact,
I got confused for a second. I see him online, that's why.
oh man, he was. I only really spoke to him a couple times, but every single time he was very pleasant. Just reinforces the idea that all the mages in our guild are wholesome. Anyways,
Most, I gotta say though, yeah, all the mages in our guild are actually pretty cool.
I'd be